In this video, we're going to continue looking at exponential and logarithmic equations. This time we're going to focus on exponential equations. And in particular, we're going to start with an easier example of when they have the same base. So what these exponential equations will look like is we'll have something to some power on one side, something maybe to some power on another side, and we're going to try to solve it with our variables being in at least one of the exponents. So there are two ways to solve these. One of these is going to be a little bit more useful than the other, and one of them is going to be just faster if it works. So our first way will be to make the bases the same and then set the exponents equal. So we can see already this may have a limitation. We would only be able to solve it if the bases are the same. But that's okay. In this section, they're all going to be the same. Now, the second way is going to be a little bit more useful, but sometimes a little harder. In this way, we'll take the log of both sides and then solve. So you can see because we're taking the log of both sides, it's going to make it a little bit more complicated, but we have calculators. We can just put these values that we're getting in at the end, and if we do everything right, they're both going to come out to be the same. So let's look at this first example. I'm going to do it both ways. 1 over 3 is the same thing as saying 3 to the negative 1 power. So I'm going to go ahead and just start by writing that. And then, if we remember from our review from last time, or even just module 8, exponents to exponents are multiplied. So we can just go ahead and start off by rewriting this as 3 to the negative x equals 81. Now, we have this as base 3, and we're not going to be able to change this very much. So we want to change 81 to be 3 to some power. So 9 times 9 is 81, so that means this is 3 to the 4th is 81. And now once we do that, really we're solving this top equation. Negative x is equal to 4, so x is negative 4. So there was a little bit of trickery. We needed to know how to convert 81 to be base 3. Otherwise, this was pretty straightforward. Now, for our other way to do this, I'm going to take this equation and I'm going to take the log of both sides. All right, now we have this one trick from our properties of before. If I have log of something to a power, that power comes out to the front. Now the weirdest part about this is log of 1/3 is some number. So we can treat it like a number. We can just divide both sides by log of 1 over 3. So x equals log 81 over log 1/3. And if you put this in your calculator, you'd actually get negative 4. It doesn't look like it, but that's what you would get. So we can see here both of these ways to solve exponential equations is going to give you the same thing. Using this log way, it looks a little bit more complicated. But we didn't have to know how to change 1/3 to an exponent. We didn't need to know how to change 81 to an exponent. So both ways have some good and some bad. So let's try our second example. And again, I'll use both ways. For here, I'm looking at the bases and I see 4 and 2. So I'm going to guess that my base they'll have in common is going to be 2. And I can rewrite 4 as 2 squared. And again, exponents to exponents will multiply. So we can see here, now that I have the bases the same, I'm really just solving this top equation. And I can do that pretty easily. Negative 10 over 4, which is the same thing as 5 over 2. Pretty straightforward. And again, since it was 4 and 2, it wasn't very difficult to make the bases the same. Now let's see what happens if I tried to do the log of both sides. All right, so again, using the same property, my exponent will come to the front. And I'll make sure I use parentheses to make that very clear. And now here's where things get a little trickier. If we're using our calculator, you might be inclined to toss this in, start multiplying it out, and you'll start to get some pretty nasty decimals. For this one, if we look, let's say I divide log 2 on both sides, something that you may or may not have thought of to do quickly. And if you put this in your calculator, this log 4 over log 2, you'd actually get 2. And that's why when the bases can be written as the same, it's usually much, much easier to rewrite the bases as the same and go from there, rather than introducing these logs. Because we can see now at this point, we're already at where we were at on the second line from before. So using the logs isn't as efficient, but we didn't have to change the bases. All right, and you can guess where we're going to go with the next video. In the next video, we won't really have a choice, and we'll see how that affects how we solve these exponential equations.